everyone, and welcome to another lab. This is going to be lab number 3 in AWS security series, and lab name is Encrypting Data at Rest using AWS KMS. So KMS is Key Management Services. So we will dive into this lab, and the lab overview and objective is: in this lab you will use the AWS key management services to encrypt data at rest. You will create an AWS KMS key, use it to encrypt objects stored in Amazon Simple Storage Service, and use it to encrypt Amazon Elastic Block Storage volumes. You will also see how AWS CloudTrail provide an audit log of AWS KMS key usage and how disabling the key affect data access. After completing this lab, you should be able to do the following: create an AWS KMS customer managed key to encrypt and decrypt data at rest, store an encrypted object in an S3 bucket by using an encryption key, attempt public access and signed access to encrypted S3 object, monitor encryption key usage by using the CloudTrail event history, and encrypt the root volume of an existing Amazon Elastic Compute Cloud instance. Disable and re-enable the AWS KMS key and observe the effect on data access. So this scenario is the following diagram shows the architecture that was created for you in AWS. In the beginning of the lab, we have S3 and a bucket name image bucket. Then we have AWS KMS. We do have Amazon Elastic Block Storage, in which we have unencrypted root EBS volume, which is attached to lab instance, and we have CloudTrail. And by the end of this lab, the artifact will look like this. So the image bucket would be block encrypted by SSE KMS, and AWS KMS encrypted data key stored as metadata with encrypted object. So we would encrypt image bucket using AWS KMS, and it says here like request to encrypt or decrypt by using this customer managed key. Similarly, we use AWS KMS to encrypt EBS, and we have encrypted root EBS volume, which is attached to lab instance, and that is attached to CloudTrail audit log of AWS KMS key usage. And that's it. So task 1 is creating an AWS KMS key. So in this task, you will create a customer managed AWS KMS key. The AWS KMS key that you create will be used later in the lab to generate, encrypt and decrypt data keys. The data keys will be shared with other AWS services, including Amazon S3 and Amazon EC2. The data keys will be used to encrypt the actual data stored in an S3 bucket and on EBS volumes. first let's go to KMS, key management services. Choose key management service and then go to customer managed key, and let's create key. Key type is metric. So metric is a single key used for encrypting and decrypting data. And choose next. For name it's going to be my KMS key. Choose next. And then for key administrator, search for and choose the voclab role. So the key administrator are users or roles that will manage access to the encryption key. You are currently logged into the console with the voclab roles. This user role is displayed in the upper right corner of the console to the left of AWS region, and choose next. On the define key usage permission, it says search for and select voclab. So key user are the user or roles that can use the key to encrypt and decrypt data. Now select next, and let's finish creating this key. So it says success. So next task is task 2, which says storing an encrypted object in S3 bucket. So let's go to S3. Go to buckets and we'll choose image bucket. In default encryption section, notice that the setting is currently enabled. So now upload a file to bucket and store it as an encrypted object. Let's upload a file, add file. Let's go to download and add this image and upload. Go to properties section and configure the following. In the server side encryption settings section, this needs to be done before adding an object. So let's try to upload a file again. Let's add this file, name it as and in properties and server-side encryption setting section, choose specify an encryption key, and then encryption key type, choose AWS key management service. And then AWS KMS key, choose from your AWS KMS key. In AWS KMS key drop down menu, select my KMS key. And let's upload this file. So it says, notice that clock P and G is now listed as an object in the bucket, and the following diagram and description explain what transpired when you uploaded the file to Amazon S3. Step 1 is explanation. The user requested to upload a file and store it as an encrypted object in image bucket. Step 2, Amazon S3 requested a data key from. So step 1, it says user requested to upload just a second. So step 1 is user requested to upload a file and store it as an encrypted object in image bucket. Step 2 here is Amazon S3 requested a data key from AWS KMS to encrypt the file. And step 3, AWS KMS generated a plain text data key and encrypted the data key using the customer managed key, my KMS key. And then in fourth step, AWS KMS sent both copies of data to Amazon S3. And fifth is Amazon S3 encrypted the object by using the plain text data key and stored the object and then delete the plain text data key. The encrypted key was kept in the object metadata. Next is analyze the encryption setting on object. It says choose clock PNG and go to properties, find server side encryption. It says notice that server-side encryption using SSE KMS is enabled on this object. In this task, you analyzed the encryption setting on the bucket and you then uploaded an object to the bucket. Although the bucket's setting do not automatically encrypt objects that you uploaded, you had the option to encrypt an object that you uploaded. Task 3 is attempting public access to encrypted object. In this task, you will attempt to access the encrypted object by using S3 object URL. This URL is a method to access an S3 object from public internet. So let's attempt to open the image using S3 bucket URL. Go to object overview section and copy the object URL and paste it into a new browser tab. And you receive the following access denied error. Yes. This is because public access to object is not allowed. The default block all public access security setting is applied to this bucket and all objects stored in it. So keep the browser tab open because you will return to this page in a moment. Return to the browser tab where the Amazon S3 console is open. And modify the public access permission for the bucket. So it says block public access. We are going to edit this and I unselected block all public access and save the change. It says enter confirm. Now it says modify the access setting for the object. So inside permissions under object ownership, choose edit and then choose ACL enable and select the checkbox for the acknowledgement. Keep bucket owner preferred selected and then choose save settings. I must acknowledge ACL, yes. Now go to object, select clock PNG, go to actions and make public using ACL. Choose make public. And now this is done. So next is test access to object again by using S3 object URL. You now see a different error displayed. Instead of access denied error you saw earlier, you now see the following invalid argument. Access analysis is access to object is now granted to public internet. However, because the image is encrypted, you are still not able to view it. This is a good thing because it demonstrates an important region that you might use to encrypt data. In cases where access to data might be accidentally granted to someone who should not have access, the person won't be able to read the data unless they also have the access to the encryption key. So the encryption key is needed to decrypt the data and make it human readable again. So next, task 4 is attempting to signed access to encrypted object. So in this task you attempt to decrypt the encrypted object from within the Amazon S3 console as an authenticated user. So open the stored encrypted object in Amazon S3 console. Make sure you are on the objects tab for the bucket with image bucket in its name. Select clock.png and then choose open. This image is different, but I have uploaded this image, so yeah, the thing is same. Analyze the URL that was used to successfully decrypt the object. Notice the URL in the browser tab where the image is open. The format is similar to the following, where the value contains credential information. Close the browser tab where the image is loaded and then return to Amazon S3 console. The following diagram and description explain what transpired when you request to open the stored encrypted object. So first you requested to open the object. Next, Amazon S3 notice that the requested object was encrypted because you were authenticated to the AWS account when using the Amazon S3 console. The signature for version 4 authentication information was automatically included in the request. And in third step, Amazon S3 then sent an encrypted copy of data key that the object was encrypted with to AWS KMS. And in fourth step, AWS KMS then decrypt the data key by using the my KMS key, AWS KMS key, which never leaves AWS KMS service. And next is AWS KMS then sent the plain text data key back to Amazon S3. And finally, sixth step is Amazon S3 decrypted the ciphertext of the data object, allowed you to open the object, and deleted the plain text copy of the data key. Task 5 is monitoring AWS KMS activity by using CloudTrail. In this task, you will access the CloudTrail event history to find events that are related to your encryption operations. The CloudTrail audit log functionality provides an important security feature, and it is a good idea to monitor how AWS KMS key are used in your account. So let's go to CloudTrail and choose event history. Now it says filter the event history to display only event that AWS KMS service reported. Choose the drop down menu on the left that currently displays read only and choose event source and enter KMS. Analyze the generate data key event. Choose the link for generate data key, and in the event record section observe the detail of the event. So analysis. This event was generated when you requested to upload the clock.png file to Amazon S3. Your action prompted AWS KMS to generate a new data key, and if you go to AWS KMS console and look at the key ID of the AWS KMS key that you created in task 1, you will find that it matches the key ID in the event record. Notice also that the event specify the ARN of the object that Amazon S3 plan to encrypt with the data key. So here it is the event time, event source, event name is generate data key, and then key spec, requested ID, account ID. So next is analyze and decrypt the decrypt event. Go to event history again. Choose the link to decrypt event. So this event was generated when you successfully opened the clock.png file from the Amazon S3 console. Notice that the record again detail who made the request. Which AWS key provided the encrypted data key back to Amazon S3 and which S3 object was decrypted with plain text data key. So it says CloudTrail logs. This doesn't make much sense to me now, but this is all about what we have done, what kind of event is being done, what type of role, and this is basically all the metadata about the function or the work we have done to encrypt and decrypt the data and to access the encrypted data basically. So like it says invoked by AWS internal, and then event source is this, event name is decrypt, region is given, source IP address, and the encryption context as well. So CloudTrail logs all AWS KMS API activity. By evaluating these log entries, you might be able to determine the past usage of a particular AWS KMS key. If you want to be able to analyze event that occurred more than 90 days ago, you can create a CloudTrail trail. Task 6 is encrypting the root volume of an existing EC2 instance. So in this task, you will encrypt the root volume of an existing EC2 instance. To encrypt an unencrypted volume, you need to complete multiple steps. The following diagram and description explain this step. So first we need to detach the unencrypted volume, then we create a snapshot, then encrypt it, and then again attach to it and start the lab instance. So let's go to EC2. Go to instances, go to lab instance and choose storage. In the block device section, notice that the volume is attached and we need to deattach it. And it also says that it is not encrypted. No. Now first we need to stop the instance. Next we go to storage. We selected block, we selected the volume ID which we want to deattach. Now we go to action and create snapshot first. Create snapshot. Let's add a tag, enter name. Name is going to be snapshot and value is unencrypted root volume. Let's create snapshot. So data lifecycle manager default policy for EBS snapshot status failed to fetch default for policy status. But it says successfully created snapshot. That is what we need to create. So move on next step. We will go to 21 number step which says create an encrypted volume from unencrypted snapshot. So in the navigation pane under elastic block storage, go to snapshots and choose the link for unencrypted root volume. Snapshot status is completed, yes. Next is, it says notice that the encryption status of the snapshot is not encrypted. Then it says go to action, create volume from snapshot. Availability John, and then select encrypt this volume. KMS key is my KMS key and choose create volume. Next is label the volume. In the navigation pane under elastic block storage, go to volume. Notice that 2 volumes are now listed. For volume with volume state of in use, this one, change the name of the change the volume name over the name. Okay, what is the name? Old, it says old unencrypted root volume. Select save. For the same step, to change the name of the volume with the volume state available, new encrypted root volume. this one is new encrypted root volume. Now swap the root volume that the EC2 instance use. Select old unencrypted root volume and then go to action, deattach volume, deattach, select new, go to action, attach volume and configure the following settings: lab instance, so it says no matching running or stopped instance in US1 East. Okay. So we are in North Virginia, right? Okay, so the old volume was in US East 1D. And we need to create this volume in the same availability zone. Let's delete this volume. Select this one, create snapshot, and select US1D and select encrypt this volume with my KMS key and create volume. And this is the new encrypted root volume. Save this. Or select this. Go to attach volume. And now we have that instance that initially we don't have. Enter /dev and xvda device name and then attach volume. Notice that the root volume is now encrypted. Return to instances, select lab instance, choose storage, and notice that the attached volume is now encrypted. Next, task 7 is disabling the encryption key and observing the effect. In this task, you will temporarily disable the AWS KMS key that you previously used to encrypt an object in Amazon S3 and encrypt an EBS volume. You will then observe the effect that disabling the key has on accessing encrypted data. Let's go to KMS. Go to customer managed key, select my KMS key and disable. Let's just try to start the EC2 instance. So it says it quickly failed to start and instance will change from pending to stopped. And try to access the S3 object by using object URL. This is the object, I think. The image failed to open and a KMS disable exception error. And displays. Even though this approach to decrypting the lab was successful for you earlier in this lab, analyze the CloudTrail event history. Now go to CloudTrail. Navigate to event history. Choose the link for disable key. It says examine the event detail. Examine the start instance event, which occurred just after the disable key event. Here is disabled key event, and so it says notice that event detail reveal an error and the EC2 instance start process. Notice that the root volume was encrypted with my KMS key. So Amazon EC2 contacted AWS KMS to provide the plaintext data key, so it could decrypt the volume, but AWS KMS denied the request because KMS key was used to encrypt the data key that the EBS volume was encrypted with was disabled. So that's why instance can't start, because the file on the root volume that the guest OS need to start couldn't be decrypted. Says go to KMS again, customer menu, select this key, select enable, then go to EC2, go to instances, select lab instance, try to start the instance. Now you will see that the instance will be successfully initiated. It says wait for the instance stage to display running. and it says running. So here we have completed all the steps of the lab. So let's submit this lab for grading. So as you can see, we have received total score of 30 out of 30. So this lab is completed. Thank you.